This week, in week 3, you will explore calculations one more time, but this week in relation to energy, protein, and fluid requirements. These are determined by an individual's age, height, weight, activity level, and medical stress. For energy calculations, the Harris-Benedict equation was our gold standard for a long time, but we now use the Mifflin-St. Jean formula, which has been shown to be more accurate than other formulas for predicting BMR, or basal metabolic rate. In other words, how many calories are burned at rest. All right, and so let's just scroll on down through here. We'll see some metric conversions. You'll see that old gold standard. And then we'll be talking in a little bit about physical activity factors and stress factors, and we'll come back to that spot. All right, so our Mifflin-St. Jean equation. Okay. Back to this point about the BMR. So once we have determined the BMR, or we also call that BEE, the basal energy expenditure, we also must include some sort of physical activity factor and potentially stress factor for hospitalized or ill patients. The inclusion of these factors results in the total energy expenditure, or TEE. And you're going to see this in your practice calculations this week in assignment 3A. So again, let's take a look here on our screen, and we have the Mifflin-St. Jean equation for BEE. And so let me just take a look here, see if there's anything else I wanted to add. Okay, so notice the height and weight are in metric measurements. You do need to know how to convert to metrics, and over time, I would encourage you to memorize the Mifflin-St. Jean formula. On our exams, I will give you that formula, but the NDTR credentialing exam will expect you to know it. Notice in the formula, you multiply weight, height, and age times a factor. You add the resulting weight and height, and then for females, you subtract what appears to be a random number of 161. For men, you add 5 pounds to the resulting height and weight. From here, you multiply a physical activity factor. Most often, you'll use 1.1 or 1.2. So let me scroll back up here, and we'll take just a look at these for a moment. And so you can see for PA, or physical activity factors, we'll see confined to bed as 1.2 times our BEE, or ambulatory or light activity, 1.1. And these other higher activity levels are really for athletes, or for some other, if a patient is involved in rehabilitation while they're healing, you might also have a higher physical activity factor. All right, and then we have stress factors. And so you can see these tend to be a range of 1 to 1.1 for minor surgery, or 1.1 to 1.3 major, and so on. This summer, you may find use of these stress factors, and your site may also have standards that they use for particular medical stresses, and you'll want to comply with using those. When we get to medical nutrition therapy next spring, you will need to include stress factors in your calculation. But for this semester, I don't believe we will be utilizing any stress factors in our assignments. Okay, so the resulting answer then is the TEE and you're finished with the equation. All right, so we have a couple of other details on this page, some other methods that are less frequently used. You will probably also find another quick calculation of energy requirements at your summer site too. So feel free to make use of those new formulas that you learn about next summer. All right, and then we have a section this week on calculating weight loss or weight gain requirements. This is a very quick, kind of cut and dry formula. It's easy to remember. And so just to fall back to information that you may have already learned in DIT 106, and that you've also read about in Chapter 8. What we actually do is take 500 calories and 500 calories times 7, meaning 7 days in 1 week. This will create a deficit or a weight gain when we multiply 500 calories times 7. No, I'm sorry, let me rephrase that. When we multiply 500 times 7, we're going to get 3,500 calories. That's a pound, equal to a pound of weight. All right, if we want a weight loss, we want to have a deficit per day of 500 calories. If we want to have a weight gain by, let's say, an elderly person who's been losing weight, we would want to add 500 calories extra in our TEE calculations. Okay, so you can read through that on your own and see my examples, but I just really wanted to highlight this for you. All right, next I'm going to scroll back up here and get to protein calculations. And these calculations are based on kilograms, so know your metric conversions. And again, just as a reminder, that's going to be your weight in pounds divided by 2.2. It gives us our kilograms. All right, so most of our calculations are going to be this healthy, non-stressed individual of using 0.8 grams per kilogram or 1.0 grams of protein per kilogram. All right, and let's go on to fluid calculations. I'm just touching on these. You'll spend more time when you're looking at these on your own. All right, and this is calculated also in kilograms, and we use one of the 3 options, either 25 milliliters per kilogram, 30 milliliters, or 35. And again, I'm going to let you sort that out, and be sure to look at our example here too. Let me just mention something about this example. The answer here for this particular person was needing 2,454.5 milliliters of fluid per day. So this is not a very familiar or friendly term in milliliters for most of us, and especially if we're talking to patients or clients. Therefore, we need to convert the total volume in milliliters to cups. Now, this is terminology that we're familiar with. So dividing that 2,400, etc. milliliters by 240 gives us the total number of cups. And it turns out that 240 is actually the number of milliliters in 8 ounces or 1 cup. So again, you can read through that calculation. Let's move on to assignments for this week. In assignment 3A, let me pull that into our screen. Oops, I have another assignment back here that's hiding. All right, so I'm going to pull that up a little bit more. Okay. And so you'll recognize this from last week's assignment. You had to fill in the first three columns: ideal body weight, percent of ideal body weight, and the actual weight in kilogram and height in centimeters. And then you also had to calculate adjusted body weight in kilograms for our third patient. Okay, so this week you're going to complete the entire anthropometric calculations table, and you pick up in the TEE column. So you want to be sure that your final answer is total energy expenditure, not BEE. All right. And I am going to encourage you to show your calculations in these little blocks. Please don't write in by hand or pencil. It's very, very hard to see a scanned document in here. So you might want to do this on scratch paper and then type the information in here. Show your calculations with two place values to the right of the decimal, so you're not rounding up at this point. Do your calculations clear through to the end of the formula with those two extra place values. Okay, let me see. All right, so you'll be doing the TEE in this middle column for patient 1 and 2, and for patient 3, you're going to calculate that TEE using the adjusted body weight that you discovered last week. And then you'll continue on with fluid requirement calculations and protein. And again, for patient 3, you're using adjusted body weight in kilograms. All right, and then you also need to convert the final milliliters to cups. So you're showing milliliters, and I would encourage you to show your calculations on all of these, because I will give you partial credit if you move through a good part of the formula but just messed up a simple point or something. All right, let's see. Then let's take a look at assignment. Just get rid of this other one. Assignment 3B. And we're back to using a partial A-dime template again. So if you recall, last week's MindTap assignment was about Mr. Woods, a 74-year-old caregiver with weight loss. We are continuing to build on those A-dime skills, and you'll again use the partial template as we see here, adding this week ideal body weight, percent of ideal body weight, and remember to base the ideal body weight on what is a healthy or realistic weight for Mr. Woods. Many of you will have had some of my comments in your answers in MindTap, so be sure to use that healthy or realistic weight. And then you add the micronutrient calculations to the A-dime form, and that's new this week also, and convert the final milliliters of fluid to cups, and that is really it for those assignments. All right, back to, all right, okay, and oops, sorry, all right, back to Blackboard. So you also notice that there is a post-test for Chapter 8. And that's everything this week. I'd like to remind you there will be a Zoom meeting on Tuesday evening in week 4, and that is September the 26th at 6:30 p.m. to discuss how to write learning objectives. And I'll set up break rooms for you to interact with your peers to practice client interview skills. You can see the types of questions to include when week 4 opens at midweek. All right, this Zoom session also will allow you to complete several of next week's assignments as a group in order to ease the burden of work. Do take advantage of it by being present for the Zoom. Have a great week.